the quadratic formula and the discriminant. Our objective is to solve quadratic equations by using the quadratic formula, as well as determine the number of solutions of a quadratic equation by using the discriminant. Why learn this? You can use the discriminant to determine whether the weight in a carnival strength test will reach a certain height. In the previous lesson, you completed the square to solve quadratic equations. If you complete the square of ax squared plus bx plus c equals 0, you can derive the quadratic formula. The quadratic formula is the only method that can be used to solve any quadratic equation. However, it's not always the quickest way to do it. The quadratic formula. It's the opposite of b plus or minus square root of b squared minus 4ac, all divided by 2a. So once again, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's put this formula to good use. So we have 2x squared plus 3x minus 5. Our a value is 2, our b value is 3, and our c value is negative 5. And now we're going to substitute these values in to our quadratic formula. So in case you're forgetting, it is the opposite of b plus or minus square root of b squared minus 4ac, all divided by 2a. So let's start substituting. So we've got the opposite of b, so we end up with negative 3 plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So now we just go through and start simplifying. Make sure you use order of operations. So we're going to deal with our 3 squared and what's underneath the square root here first. So we've got negative 3 plus or minus, and then we have the square root of 9, and then minus 4 times negative 5 times 2 is negative 40, all divided by 2 times 2, which is 4. And let's keep going. Minus a negative is like adding a positive. So we have negative 3 plus or minus the square root of 49 over 4. And we're going to keep going to the next row here. So now we have negative 3 plus or minus. We have the square root of 49, which is 7, divided by 4. Notice how you kept saying plus or minus. We're going to split it into 2 different pieces. So, one will be with addition. So we have negative 3 plus 7 divided by 4. And 1 is going to be with subtraction. So we have negative 3 minus 7 over 4. And when we simplify, we end up with 1. And when we simplify this one, we end up with negative 5 halves. So your zeros from this quadratic function are 1 and negative 5 halves. If you graph it, you will notice that these 2 points are where it crosses the x-axis. So let's try another one. So we want to move everything over to the side with the highest power. So we end up with x squared minus 2x minus 3. And you can put the equal 0 on either side. Alright, so our a value is 1, our b value is negative 2, and our c value is negative 3. So now we're going to substitute each of those values in. So we have the opposite of b, so the opposite of negative 2 is 2, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And now we follow our order of operations. So we have 2 plus or minus the square root of 4 minus negative 12 over 2. And then we're going to continue. So we've got 2 plus or minus the square root of 16 divided by 2. And now we're going to continue on the next row. So we've got 2 plus or minus, and the square root of 16 is 4. And we divide that by 2. Once you have it to this point, we're going to do one with addition and one with subtraction. So we have 2 plus 4 divided by 2, and now we've got to do the one with subtraction. So we have 2 minus 4 divided by 2. And we end up with x equaling 3 or negative 1, the two zeros of our parabola, or quadratic function. Take a moment and pause the video and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it, your two zeros. Many quadratic equations can be solved by graphing, factoring, taking the square root, or completing the square. Some cannot be solved by any of these methods, but you can always use the quadratic formula to solve any quadratic equation. So let's use the quadratic formula to estimate a solution. So our a value is 1, our b is negative 2, and our c is negative 4. So we have the opposite of b, plus or minus square root of b squared minus 4 times a times c, all divided by 2a. And now we're going to use order of operations to simplify. So we've got 2 plus or minus the square root of 4 minus negative 16, all divided by 2, which then continues to simplify. So we have 2 plus or minus the square root of 20 over 2. The square root of 20 is not a perfect square. All the ones that we had done previously have all been perfect squares. So this is going to give us a decimal, which means that we're going to have a solution that we have to estimate. It's not going to be exact unless we leave it in something called simplest radical form. You will be learning about this later. So let's simplify what we have and estimate our solution. So we end up with 2 plus the square root of 20 divided by 2, and we end up with 2 minus the square root of 20 divided by 2. And when we simplify, we end up with about 3.24 and about negative 1.24. So you have an estimated set of zeros. You can't factor and get zeros like this. It isn't going to work. Graphing would be really difficult to see. However, the quadratic formula will give it to you. Alright, so now let's look at the discriminant. The discriminant is the equation b squared minus 4ac. It's the part under the radical sign. As you all know, a quadratic equation can have 2, 1, or no real solutions, and you can determine the number of solutions of a quadratic equation by evaluating its discriminant. Notice how when you find the discriminant of this first one, it's positive. And then if you graph the related function, you notice that there are two x-intercepts. Therefore, if the discriminant is positive, there are two real solutions. If we go over to the next one, our discriminant came out to be 0. If we graph it, notice how the vertex lands on the x-axis. This means that there's one real solution. And then if the discriminant is negative, notice how the graph of the related function, it never crosses the x-axis. So there are no real solutions. Here's a quick summary of what we just talked about. So if b squared minus 4ac is greater than 0, there are two real solutions. If it equals 0, there's one real solution. And if it's less than 0, there are no real solutions. Basically, positive, 0, negative. Negative means no, 0 means 1, and positive means 2. So now let's practice. So let's look at this first one. The a value is 3, the b value is 10, and the c value is 2. So now we just want the discriminant. It was what's underneath the square root. So you have b squared minus 4ac. So 10 squared minus 4 times 3 times 2. So 10 squared is 100. And 4 times 3 times 2 is 24. So minus 24. And that gives us 76. So it's positive. So therefore, there's going to be two real solutions. Take a moment and pause the video and try B and C on your own. When you return to the video, the answer for both will be revealed below. And there you have it. The height h in feet of an object shot straight up with an initial velocity v in feet per second is given by h equals negative 16t squared plus v times t plus c, where c is the beginning height of the object above the ground. So let's look at a physics application. A weight 1 foot above the ground on a carnival strength test is shot straight up with an initial velocity of 35 feet per second. Will it ring the bell at the top of the pole? Use the discriminant to explain your answer. So if we look at our diagram, it goes up to 20 feet, so that's our height. And then we use our formula. We've got negative 16t squared plus, and then it told us that our initial velocity was 35, so that's your v. And then we have t, which is our time, plus 1 because it's starting 1 foot above the ground. So we need to get everything to the side with the highest power. So we're going to move our 20 to the other side, and we've got negative 16t squared plus 35t, and then when we subtract 20, we're going to end up with negative 19. And now we can use our discriminant. So we have 35 squared minus 4 times negative 16 times negative 19. And when we simplify this, we end up with 9. The discriminant is positive, so the equation has two solutions. The weight will reach a height of 20 feet, so it will ring the bell. This is a summary of each of the methods you have learned throughout this entire unit. We've done graphing, factoring, using square roots, completing the square, and, as of today, using the quadratic formula. Here are some advantages and disadvantages to using each. And this ends our lesson on the quadratic formula and the discriminant, as well as the unit.